In lesson 2.6, you guys noticed in your explorations, hopefully, that we start doing what are called flow proofs or flowchart proofs. Okay, they're the same thing as a two-column proof, they're just written differently. Okay, so don't think they're any easier or harder. Okay, maybe organizational-wise, you might like them more or less. Okay, that's a possibility. But they're the same exact thing. So, we will do that here in a second, but before we do that, we need to talk about our first theorem. Did you guys get all your theorems on your theorem sheet like I asked you to yesterday? Did you do that one postulate on there also? Okay, you shut that please. Thank you. Just so I know you're with us. Okay, the first theorem that we had is called the right angles congruence theorem. Hopefully, when you guys wrote that in your theorem sheet, well, let me ask you this. What was your reaction when you wrote that in your theorem sheet? That one did?
Maybe not that one.
But all of them together took up a lot of space? Yeah, I believe that. What about that one specifically? Look at it if you don't know what I'm talking about. Check it out. What was your reaction when you read that theorem? That you already knew that? Yeah. Self-explanatory. I had a student third period tell me they thought, duh. Right? Well, why are they saying that? Why are they saying duh? Because if they're right angles, what has to be true? They're 90 degrees. Well, if they're 90 degrees, then obviously they all have to be congruent to each other, right? Okay, so that's why that student said that. That theorem literally just says all right angles are congruent. Okay? Your theorems are going to save you time and steps and proofs, basically. Okay? Technically, if I had two angles that I said were right angles, and I wanted to prove them congruent to each other before I had this theorem, technically I would have first had to say that they were right angles. Then I would have had to use the definition of right angles and say they equaled 90 degrees. And then I would have to use the transitive or substitution property and say they were congruent to each other. Actually, then I'd had to use it and say they were equal to each other. And then I'd had to use the definition of congruent and make them congruent to each other. Okay, so it's going to cut out some steps. Because now, as soon as we know they're right angles, now we know they're congruent. Okay, I'll show you a theorem here in a little bit that cuts out like 5 steps. Okay, they're just going to make them easier as we go on. So we have to do less steps. This first example I want to do as a flow proof. Okay, so I have a rectangle A, B, C, D. And actually, before I do this, this morning I had a class that didn't want to do anything. Like, they wanted to sit and just watch and didn't want to take notes, didn't want to participate. Even if you are not the one actually telling me what to do next in the proof, will it benefit you to be doing things in your head, at least taking guesses in your head? Yes. Hey, if you literally sit there and just stare at the board like I had 16 students do in one of my class periods this morning, is that doing anything for you? No. Hey, write things on paper, take your notes. If you're not going to be the one who's gutsy enough to give me an answer, hey, which honestly in this, who cares if you're wrong, because I know that, and everybody else knows that you've never done these before, right? So who cares if you're wrong? Hey, everybody's going to be wrong. Hey, if you're not going to be that person to take a chance, at least be doing things in your head and trying to get things right in your head. Okay, that will benefit you. If you don't do that, you're probably really going to struggle as we move on to assessments. Okay, so do that for me. Even if you're not the one saying it out loud, do it in your head at least. What we are trying to prove here is that angle D, I don't know why I wrote 2. I'm going to write it in alphabetical order. Angle B is congruent to angle D. Okay, that's what we're trying to prove. Okay. And they give us that segment AB is perpendicular to segment BC. That's a given. And they give us that segment AD is perpendicular to segment CD. I don't know why that's not working. Interesting. I don't know why that wouldn't work. It's worked all day long. Huh. I got nothing. Interesting. Well, hopefully it doesn't cause us any issues, I guess. So, the nice thing about flow proofs is you will easily be able to tell if you've used your givens or not. You guys remember when we were doing 2-column proofs and I'd put check marks next to the givens after we used them? Okay? This will be very obvious because if you've used this, then you're going to have an arrow coming off of it. If you don't have an arrow coming off it, you haven't used it. Okay? So, we need to go through, and this proof is a little interesting. This won't happen a ton, but occasionally. I start with information about segments, and I move to information about angles. Okay? So we have to somehow make a statement from our givens that tells us something about an angle. What is it, William? Okay, is it okay if I just call angle ABC angle B, since there's only one angle there? Okay, so let's do that. Angle B is a right angle. And I'm going to mark it. I'm going to put that mark there for us. Why? Well, okay, yes. I'm going to put the mark there so I know I already did it. But why is angle B a right angle? Right, so if you're telling me it's a right angle because they're perpendicular, you're using what definition? Definition of perpendicular. If you're saying that's true because they're perpendicular, you use the definition of perpendicular. The definition of perpendicular is that if two lines are perpendicular, then they form a right angle. Right? So when I say it like that, we definitely use that, right? Okay. What does this tell us down here? That AD is perpendicular to CD. Angle D is a right angle. And I'll put that mark up there. Why is angle D a right angle? What would the reason be? Definition of perpendicular again. Exactly. Definition of perpendicular. Exact same reason as I had above, right? Okay. Is it possible for me to prove that angle B is congruent to angle D yet? Yeah, because we just learned that theorem, right? We just talked about that theorem that says if they're both right angles, then they must be congruent. So now I would take arrows, and I would say that angle B is congruent to angle D. I still do need a reason for that. Definition of right angle says if it's a right angle, then it's 90 degrees. Right angle congruence theorem. If you want to just abbreviate it like that, that's fine. Right angles congruent. Okay. Now, I did have a little bit of confusion in one class. This was actually the other day. They wanted to list things for reasons like they add to blank or they are perpendicular. Remember, if you're putting it as a reason, we're using deductive reasoning, right? So all of your reasons are either going to be definitions, laws, properties, reflexive, symmetric, transitive. Maybe they're postulates, theorems. Okay? They have to be something that is factual. You can't just say, because I added. Okay? Well, if you're saying because you added and you did it on both sides, you're using the addition property, right? Okay, so just understand that. It's got to be a property or a definition, theorem, postulate, something like that to go in a proof. Okay, you can't just say because it's true or something like that. Okay, that doesn't work. Okay? Alright, so the next thing I want to do is on page 107, take a look at our next two theorems. The first one is called the congruent supplements theorem. Okay, now, this theorem we've actually already proved to be true. Do you guys remember, I think it was Tuesday, I can't remember if it was Tuesday or Monday. Okay, people listening to the video are going to have no idea what I'm talking about, but that's okay. We did a proof, and the diagram looked like this. Anybody remember doing that? Okay, at least vaguely. Okay, that was the congruent. It was a proof of the congruent supplements theorem. Okay, and then I gave you the information. Your given information said that angle 1 is supplementary to angle 3. And it also said that angle 2 was supplementary to angle 3. Looking familiar? You guys with me on what proof I'm talking about? We did it, like I said, I can't remember what day it was. It wasn't very long ago, though. It was this week for sure. Then, what did we end up proving to be true? Does anybody remember? 1 and 2 were what? Congruent. Then we said that angle 1 was congruent to angle 2. Okay, that is the congruent supplements theorem. Okay, we proved that the other day. I think I might have in your class even used the example, well, what if I said 3 was 100 degrees? Well, if 1's supplementary to 3, then it must be 80. And if 2's supplementary to 3, then it must be 80. Right? Well, they're the same. Okay, I don't remember. I think I did that in your class. I know I did it in some classes. Okay? So, we've already proved this theorem. Okay? What I don't want to happen is don't forget about this theorem. This is one of the most commonly forgotten about theorems. Does anybody remember how many steps it took us to prove it? It was 6, I think, in this class. It was either 5 or 6, depending on how you did it. I think this class we did 6. It took 6 steps. With the theorem, you can do it, well, in 2. You would have to state this, and then you could automatically go to this. Okay? So you cut out 5 steps. Okay? It makes a big difference, right? Okay, so this is one of those that people commonly forget about. The next thing I want to bring up while we're talking about that is the biggest issue that a lot of students have had in the past when they don't know what to do on a proof next, okay, is the fact that they aren't using their theorem sheet. Okay, they come to me, they say, I'm stuck, I don't know where to go next. My first question will always be, unless I can see it, where's your theorem sheet? Typically the students that are having the most issues are like, oh, well, 1 second, let me go get it out of my folder. Or something like that. Okay, they're not even trying to use it. Use it. Okay, that's why I give it to you. I don't expect you to memorize all of this, right? That'd be a lot to memorize. I don't expect that. So utilize that when I give it to you. Okay, I don't expect you to know all those words, but I expect you to be able to find them on your theorem sheet. Okay? So, if angle 1 is supplementary to 3, and 2 is supplementary to 3, which supplementary means they add to 180. If that's the case, 1 and 2, whoa. I don't know what's going on with my board. 1 and 2 must be congruent to each other. Okay? The next theorem is essentially the exact same thing, except instead of congruent supplements, it says congruent complements. What is the difference between supplements and complements? Two angles that add to 90 are complements. Two angles that add to 180 are supplements. So this diagram is going to look a little bit different. However you want to do that last one, I guess I'd rather this be the angle 3. But really the theorem reads almost the same. If angle 1 is complementary, there's the only difference, to angle 3, and angle 2 is complementary to angle 3, then angle 1 must be congruent to angle 2. Has to be. It's the exact same theorem, but instead of the word supplement, it uses the word complement. Okay, instead of being 180, adding to 180, they add to 90. Okay. If you take a look at example 2, right below those theorems, that is the proof that we did the other day. It's the same exact one. The only difference is back when we did it, we hadn't learned the transitive property yet, so we use substitution instead. Okay, otherwise it's the exact same thing. Okay. So we're going to skip example 2 since we've already done it. Flipping the page, now we're on 108. It talks about a paragraph proof. Just the name paragraph proof tells you that you're doing a proof in what form? A paragraph. Okay, you would be writing it out. The benefit you guys have is you're on a computer. Do you write anything out? No. Okay, so you know as you go through this, you're not going to have to do the whole thing. They're probably going to give you options and you're going to have to fill in the blanks, right? Okay. I suggest that you make sure you read from the very beginning of those proofs. That's a common mistake that I see, is people try to just jump to the first blank and figure out what goes there. Read it. It probably gives you a little information there. Okay. We'll do a paragraph proof here in a little bit. I want to talk about this postulate and theorem first, though. Okay, we have a linear pair postulate. This is one that I asked you to put on your theorem sheet. Occasionally we will have postulates that I ask you to put on your theorem sheet. This was one of them. Okay. Hopefully the diagram looked very familiar to you. We have worked quite a bit already, not recently, but in the past, with linear pairs. Before we even read the postulate, what do you know that those two angles should add to? 180 degrees. We did a bunch of problems like that. You remember those? It's been a while. That was back in chapter 1. Okay, but we did some of those. Okay. Your postulate says that if angle 1 and angle 2 are a linear pair, then they are supplementary. Which is the exact same thing that you guys just told me, the fact that they add to 180. That is supplementary. Any specific questions on linear pair postulate? Okay, we kind of already knew that one. Or should have. You should have known that at least that they add to 180, and you should have known that if two angles add to 180, then they're a linear pair. Or excuse me, then they're supplementary, which is linear pair. It's all really the three are all really the same thing. Okay. The last theorem before we do two last example problems. This one is called vertical angles congruence theorem. We have also worked with vertical angles in the past. Paul, can you give me one pair of vertical angles? 2 and 4. Does everybody agree? Okay. This theorem says if they are vertical angles, they must be congruent to each other. So, if Paul says 2 and 4, that means angle 2 is congruent to angle 4. Okay. So what other angles must be congruent? 1 and 3. This theorem is going to be a lifesaver for you. You are going to use it a lot. It should be your best friend. If you guys need a best friend, you can be best friends with vertical angles. What's that? Okay. That one shouldn't be too difficult for us. All right. So like I said, I got two examples here. I have, this is 101 degrees, and this is 4x minus 3 degrees. They want us to solve, gosh darn it, I don't know why that doesn't work. That's going to drive me nuts. I use that feature a lot. Play with it over lunch, I guess. I don't know. Yeah, I wish I could get a new one. That board's like 15 years old. I think they'd be mad at me. Tell them Bo did it. Alright, so how would I solve this? If I'm trying to solve for x, what do I need to do? 4x minus 3 equals 101. Why? Hey, if I had to have you write a reason, that's exactly what you'd say. Vertical angles are congruent. Since they're congruent, I know that those two things must be equal to each other, correct? Okay. And then from there, I could go on and solve this, and I would add 3. 4x equals 104 because of what did I do to both sides? Addition. I added. So that'd be the addition property of equality. And then last step, divide by 4, and x equals 26 because of the division property of equality. Okay? That one shouldn't be too hard. Like I said, when you see vertical angles and they're asking you to solve, hopefully you're thinking that that's going to be an easy problem. Okay? I have one last example. And I want to see if this does anything for me. Nope. Okay, one last example. They give me this diagram, and we're going to do a paragraph proof on this one. Okay. Yeah. And they tell me that angle 1 is congruent to angle 4, and that's my given. So that is given. So I'm going to go ahead and mark that. And we are trying to prove that angle 2 is congruent to angle 3. Okay. So somehow I got to get angles 2 and 3 into my proof, right? Okay, so let's start there. What is, just looking at 2 and just look at 2 by itself, I guess, and 3 by itself. What's something I know must be true based on information we've talked about today? Hey, what about vertical angles, Jersey? Well, they are vertical angles, but our theorem we just did says vertical angles are congruent. So what 2 angles must be congruent then? 2 and 3 aren't vertical angles. 3 and 4, and did you say the other one? 1 and 2. So you can say then that angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4 because of the vertical angles congruence theorem, and I'm abbreviating. Okay. So that's good. I got 2 and 3 into my proof. Have I used my given yet? No, not yet. I'm going to go ahead and mark these. 1 is congruent to 2. 3 is congruent to 4. So I do see just with my markings that they are going to be congruent. I just got to figure out how to get there. I want you to look at that given, and I want you to look at the first pair of angles we said are congruent. So it says 1 is congruent to 4 and 1 is congruent to 2. What's that? I could substitute what? The 4 for the 2. So 1's congruent to 4. We already have that. So you're, okay, Tegan's doing it a little bit differently than I would. So you're saying, oh, are you saying take the 4, and since it's congruent to 1, put a 1 here? Yeah. Is that what you guys are saying? There's like 3 or 4 different ways to do this proof. Yeah, you could do that. So you're saying, Bo's saying, since this is a 4 and this is a 4, let's take this 1 and put it here. Right? That works. Let's do it. We haven't done it that way yet today. So then you're saying that angle 3 is congruent to angle 1, right? Because of, we need a reason first. Why is 3 congruent to 1? What do we do? Okay. It could be the transitive property, because if 1's congruent to 4 and 3 is congruent to 4, then we can call that the transitive property. Okay. Now I have 3 congruent to 1 and 1 congruent to 2. So if the 1's congruent to 2, then I could take the 2 and plug it in here for the 1, right? And I could say, so angle 3 is congruent to angle 2 due to, you called it substitution. That works. I'm close. I'm not exact yet, so what do I need to do? I have 3 congruent to 2. They want 2 congruent to 3. Not reflexive. Symmetric.
If I could have your attention, please. We are entering into a lockdown at this time. Lockdown, lock, light, out of sight. Lock.
Okay, so as this comes on, you guys will slowly start to be able to see it. We flipped that around. We said angle 2 is congruent to angle 3 due to the symmetric property. Okay, we lost this mark somehow. Okay, so then we have exactly what they want. If you wanted to, you could put that into a 2-column, hopefully, or a flow proof. Okay? Questions on any of those? Okay, so go ahead and get started on your